Now let's look at the two examples we just saw. This is the first smaller examples that demonstrates how the array name alone and the array name with an ampersand in front of it, or how the reference to the zeroth array element with an ampersand in front of it, how all three of these are actually the same. This is the code from the example that you saw. Let me show you the output first. All we're doing is we're printing out array 0, ampersand array 0, and ampersand array. So let me just fix that. I think I missed the ampersand over here. How they basically all refer to the same memory location. Fix the spacing, and there you go. Nice and lined up. And now you can see that all the pointer addresses of all three of these are the same. So you can use this notation or this notation or this notation. Obviously, the first one is the simplest one, and that is what we typically use to pass an array by reference. When all we're trying to do is send the address of the first element of that array. Let me also take this opportunity to show you something else. Now you see that I'm using a single printf statement and a single line of code to basically do what we would otherwise have done with 3 printf statements. It's not very readable. So here's something you can do while still using a single printf statement. Check this out. You can break up this string argument given to the printf statement. You can break that up over multiple lines like this. Even move these a little bit here and there to make it more readable. And you can see this is still a single printf statement, but we've broken it across 3 lines over here. And notice there's no comma between the different strings and double quotes over here. So what I've done over here, I've broken up the single string for the first argument, the string. I've broken it up into 3 strings and put them on 3 separate rows. Let me run this just to show you that this will not create an error. The output is unchanged. Well, with the exception of the address locations, of course. Every time we run the program, the memory location where this array is created, that may change. So this is a neat trick that I thought you might want to know. Now let me jump to the second example. Not this one, this one. Okay. So let's begin with the first version, in which we do not have the try to modify array function yet. So we have only 2 functions, modify array and modify element. The first one takes the entire array by reference as argument. Second argument is the size of the array. The second function, modify element, takes a single integer element from that array as argument. And here in the main function, we have main function a of size 5 defined as a symbolic constant over here, size 5, and initialized to 0, 1, 2, 3, and 4. String here saying effects of passing entire array by reference. Values of the original array are, and then we print out in a for loop, we print out the 5 elements of array A. Counter variable is I. New line, we call the modify array function, pass it array A, as you can see, just by giving its name, no ampersand, nothing. And we pass as second argument the size of the array. And once we come out of this, return from this function, print out another string, the values of the modified array are, and we print out all 5 values of A again, just like we did before. And here we expect to see the values 0, 2, 4, 6, and 8 printed out. Then we try out the modify element function. So first we print out the value of A3, which is by now 6, coming out of the modify array function. It's 6. That'll be printed out by this printf statement. We call modify element, pass it A3 as argument. Inside the modify element function, that is received as an integer e, which is multiplied by 2 and printed out right from inside this function. Then back in the main function, we return from modify element and print out the value of A3 again, and we'll see that it'll still be the old value 6 because we passed A3 by value. So this modification, this multiplication by 2 that happened to E in here does not affect the values in original array A. Run that. Okay, I have to comment this function out, of course, which I didn't do, creating problems. There you go. Effects of passing entire array by reference. So initial values are 0, 1, 2, 3, 4. We call the modify array function, come back from that, and the values are in array A are now changed, multiplied by 2, all of them, 0, 2, 4, 6, and 8. We then call, we then print out the value of A3, which is 6, correct? And we call modify element, which multiplies 6 by 2, makes it 12. That is a local variable of modify element. So when we come back to the main function and print out A3 again, A3 is still at 6. And I kind of prematurely already showed you what would happen if I try to call this try to modify array function. Let me add a call to that at the end. Try to modify array, and this is array A over here. This is taking a single argument. Yep, it's taking a single argument. And let's see what happens. Oh, I forgot to comment. No, everything is commented in. Yep. So you can see I'm getting errors over here. Expression must be a modifiable. L value is short for left value, meaning something that you put on the left hand side of an assignment operator. So B0 over here is being, obviously the statement is trying to modify it. Can't happen because it's been declared a constant up here. So B you cannot assign to a variable that is constant. It says so right here in the error for all 3 lines, which I try to make this assignment to an array declared constant. Comment this out again. And let me remove function call, of course. There we go again.